Hello everyone, so I'm Michael Schinketz and my submission for the Zero Knowledge Proof Hackathon is ZK Minesweeper. So sure, most people know what a Minesweeper game is. It's basically you have a game between a player and a server. The server picks some random locations for mines, and he hides it from the player, and the player's job is to guess all the empty fields without hitting a mine. And the server's job also is to make suggestions with numbers. So these numbers are the number of mines that's nearby this field. So why would anybody use zero knowledge proofs for such a game? Well, the first thing is, in a blockchain context, Minesweeper is an incomplete information game, and that means that the mine location cannot be public. So you cannot really, if you play a game on a blockchain, it would be pointless to reveal the location of the mines on a public blockchain. So you need a way to ensure that this data never gets on chain, but you can still make proofs about it. And the second thing is it also proves that the server is actually honest. So during a game, for example, he cannot change the configuration of the mines. So how would this be implemented? So when the game starts, on smart contract is initialized on the blockchain, and then when a player hits some field, the server tries to prove if this field actually contains a mine or not. And additionally, he also proves that he also provides a number of mines that are nearby, and he also tries to make a proof without revealing any secret information that how many mines are nearby. So let's take a quick look at the code. So I've implemented both things, so the smart contract and also the circuit code. So I used Circom, I meant to say Socrates. So I used Socrates for the circuit code and script for the smart contract code. So in the circuit code, you have this is what basically the server uses to make proofs. So as you can see, make this a bit bigger. So you can see the mine field. It's embedded in a single field element in Socrates, and it's a private input. So this never gets revealed. What gets revealed is a commitment. So this commitment is chosen at the initialization of the smart contract, and the server takes the target that the player picks, and he tries to prove if it was actually a mine hit or not. And also he makes an assessment about the neighbor mine count. So the circuit code actually deals with that. So the proof must be correct, and it must be done on the correct mine field that was committed to. Now let's take a quick look at script code. So this is the smart contract. This one. Okay. So it's basically a standard script smart contract. It has two public functions. So one is the update function. This one is used by the server. And the other one is the reveal function. This one gets called when a player tries to make a guess, or he opens a field. So what this function does in essence, it only stores as a state variable in the smart contract the location that the player chose. and it does a smart contract update, and then the server picks that up, and then here he calls the update function, and he provides a zero knowledge proof about these public inputs. So he specifies if it's a mine and how many neighbor mines are there. So this can be then read by the player. But the smart contract also ensures that this proof actually is correct. So and the way it does this, it takes the commitment of the mine field, and this was specified on the contract initialization, so it cannot be changed afterwards. So that makes sure that the field stays the same and the proofs are all correct. And that's in the essence, that's it. So this code is publicly available. The core itself of the application works. It's even tested. You got the test file, so this goes through a whole process of a game, so from start to end basically. And the next thing is integrating it with some front end. I chose some React web front end for Minesweeper, and I tried to integrate a wallet inside it to broadcast the smart contracts and to take care of everything else. So it's still not completely done. I hope by the time you watch this video it's will be completed, but let's just try it out and hope it does something. So I think I need to comment something out. Let me try. Okay, I think it's in here. Yeah, I commented out the initialization. So let's reload this. Okay, oh, yeah, it even reloaded itself. So the wallet asks for some testnet. I mean, in this example it's for testnet, but you can also use it for mainnet. So you pay some amounts for miner fees to actually publish the smart contract. So that's the initialization. So there should be a contract, a transaction ID popping up. Oh, here it is. So if you actually open this, it should contain the smart contract. So let's try this. It takes some. Oh, there we go. Yeah. So this is the script hash. So in this output, the smart contract code is actually included, and we go from there on. But as you can see, the front end is still not completely finished. The core logic of the application is done, but the front end still needs some work to do. But hopefully, as I said, by the time you watch this video, you can try it out yourself. So it will work. But until then, the tests work fine. So if you want to try it like in a more programmer way, you can just run this test file. Anyway, that's it. So thank you for listening.